So in the 8C video, we're going to learn some theorems or interesting facts about the zeros of polynomial functions. First, we're given p of x, which is x to the fourth plus 3x squared plus 1, and we're going to find p of negative 3. So we're going to take negative 3 and plug it in for x. So that's going to be negative 3 to the fourth plus 3 times negative 3 squared plus 1. So we get 81. That's going to be 9 times 3 is going to be plus 27, and then plus 1, and that is going to add up to 109. In part B, we're going to take the same polynomial, and this time we're going to divide it by x plus 3 using synthetic division. So remember, when we divide by x plus 3, we're going to have our negative opposite of that, negative 3 in the box. And up here, I'm going to notice I have x to the fourth, so that's 1. I have no x to the third, so that's 0. I have a 3 x squareds. I have no x's, so another 0 and 1. So don't forget your zeros to fill in the spaces. Draw my line, then I'm going to drop it down. So 1, negative 3, 9, 12, negative 36. And finally, I'm going to add to get 109. Now notice this didn't say find the whole thing, but it just asked me for the remainder. And what I'm going to notice is that the remainder is 109. So here's our answer of 109, remainder of 109. Now what I'd like you to do is stop the video right now, and I want you to do examples 2 and 3. So exactly the same thing, just a different problem. So do those and then come back to pick up the video in a minute. So what you should have noticed when you work these two problems is that each time my valuing the p of negative 3 for 109 and then dividing by x plus 3 gave me a remainder of 109. The remainder always matched this, and that's going to lead to our remainder theorem. If a polynomial p of x is divided by x minus c, where c is a constant, then the remainder of this division will be the same as p of c. Now, you may have noticed over here, it's much easier to do synthetic division than it is to plug it in and raise it to the powers. So sometimes that synthetic division will be the way you'd like to go. So this says use synthetic division and the remainder theorem to find p of 3 if p of x is equal to 2x to the third minus 7x squared plus 5x minus 3. So rather than substituting, I'm going to do division, and I'm going to use the number in the box is going to match the p of 3. And I'm going to then have in here 2, negative 7, 5, negative 3. And that'll be 2, 6, negative 1, negative 3, 2, 6, 3. So here's my remainder right here, the last one always is the remainder. So that tells me that p of 3 is also equal to 3 right there. For example 5, we're going to use the remainder theorem this time to find the remainder when x to the 48th minus 3x to the 7th plus 4x cubed minus 2 is divided by x plus 1. So I'm curious, what's my remainder? And there will be reasons I'll want to know that remainder. But you can see this time to do a synthetic division, even though we may like it, it is going to there's like a million zeros, not a million, but 41 zeros in the middle here. So this actually strings all the way across the page if you try to do synthetic division. So instead, what we're going to do is we're going to calculate p, and whenever you have the x plus 1, so when it's grouped with the x, it's always the opposite because my formula has a minus in it. So I want the opposite of that, which is negative 1. So then I'm going to plug it in. I get negative 1 to the 48th minus 3 times negative 1 to the 7th plus 4 times negative 1 to the 3rd minus 2. So if I have a negative 1 to an even power, it's positive. And then here I have a minus 3. If I have negative 1 to an odd power, it's a negative 1 plus 4. Negative 1 to the third power, that's an odd power, so negative 1. and then minus 2. So I get 1 plus 3 minus 4 minus 2. So I get a 4 minus 6. So I'm getting negative 2. So my remainder then is going to be, I'll put will be, negative 2 for that problem. All right, for example 6, you're going to find k such that when x to the third plus, there's my k, kx squared plus 3x plus 2 is divided by x plus 2, the remainder is 0. There's a couple different ways to do this. I like to do it with synthetic division. So I'm going to then, since I'm dividing by x plus 2, I'll have negative 2 in my box. So it's always the opposite of the x plus 2. And then my coefficients are going to be 1. Coefficient of the x squared is k, 3, and then 2. Draw your line, drop down your 1. Negative 2 times 1 is negative 2. And now I want to add these two, so I'm just going to put k minus 2. Then I'll multiply, so I'm going to distribute it through there. So this is going to be negative 2k plus 4. And then I'm going to add it. So I'm going to add like terms. So that's going to give me negative 2k plus 7. And then I'm going to multiply. That's going to give me negative 4k minus 14. And I'm going to add my 2. I kind of got out of space there, but 2, I'm going to add it there. So that's going to give me negative 4k minus 12. So my remainder then is the result of that last, here's my remainder. And I want my remainder to be 0. So that's what that says. I want the remainder to be 0. So I'm going to take negative 4k minus 12, set it equal to 0, add my 12 over, so I get negative 4k is equal to 12, and then divide both sides by negative 4, and I get k should be equal to negative 3 for my answer. All right, so now it's time to stop the video and try the next problem that's just like this one, almost like it. Here I have if h of x is equal to x to the third plus x plus 10, find h of negative 2. So I'm going to plug negative 2 in for my x's. So that gives me negative 8 minus 2 plus 10, and my answer is 0. If h of negative 2, which is what we just did, is 0, then the remainder, so my theorem said that then the remainder when dividing by, what would we be dividing by if we plug in negative 2? We're dividing by x plus 2. So remember, these are always the opposite, is 0. So what does it mean? So what does it mean when something goes into another polynomial without a remainder? It means that it is a factor. So that means that x plus 2 is a factor of x to the third plus x plus 10. If it goes into it evenly with a remainder of 0, it's a factor. So the factor says, a factor theorem says, a polynomial p of x has x minus c as a factor if p of c is equal to 0. So example 7, you know what, I'm going to stop and start again on another video.